Thanks for coming here to listen to us. I am Erland, this is Josefin, and we work at Goldman Sachs here in Stockholm for the Data Lake team. And we will present the solution we have developed that lets our users build ETL pipelines that are independent of the storage platform they run on. So this will be a technical talk. So we will start out by describing the data lake as it is at Goldman Sachs, which is a little bit unlike the usual term data lake. We'll try to describe the features that you need to understand in order to understand how we have implemented our solution, so that hopefully you can go away from here and feel inspired and want to build or use something similar to this. So to start with, let's talk about the data lake in numbers a little bit. So the data lake is an internal platform at Goldman Sachs with a few thousand of engineers as users, and we have about 18 petabytes of data stored in this data lake, and this is distributed across 156,000 data sets and 3,000 or so warehouses where the users can access the data they want. So we store 18 petabytes of data, but every day we process about 4 petabytes of data. And the data lake serves as a centralized platform for users to store data and access the data from their own teams and from other teams. And it also so it allows them to share data. We also allow them to process data in ETL pipelines, and we manage things like some security and entitlements and so. So to go through it a bit, you have up on the right, you have a consumer. Up on the left, you have a publisher or producer of data. So one of the very important features of the data lake is to decouple the producers and consumers of data, both in time, that I can produce data today that you might want to access in a week or at the end of the month or something like that, but also technically. So for example, if I'm the producer, maybe I stream my data to the lake, I use something like Kafka, but as a user, I would like this available in an SQL warehouse, and with the lake, that is possible. And also, you don't need to talk to the producer to understand how can I consume the data. You don't need to share anything like host names or passwords, or all of that goes away. You, as a user, or consumer of the data, the really only thing you need to talk with the producer about is to be entitled to use the data. So if the data is classified or sensitive, you need to go ask them, can we use this? They approve you. And from that point on, the data lake manages the entitlements to the data. So to try and illustrate this, I'll go through a use case that we have at the bank. So as a bank, we are part of millions of transactions every day, and almost all of these need to be reported to various regulators across the world. So there is a specialized team doing and submitting these reports called regulatory reporting. And of course, in order to make a report containing the transactions, you need to get access to the transaction data. However, this data is produced by lots of different teams. You might have one team in London that are doing, bonds trading, and you might have another person in New York trading equities, and you want access to all of these, all the data they produce. So for regulatory reporting, this intermediation is extremely helpful because they can go out, they can get the data from all the different producers, they get all of it delivered into one warehouse, so they can join across all of these different data sets, or they can aggregate across them, or whatever they want. And they produce their data and they can send in the report. Another important feature of the data lake is versioning. So we never delete anything. So if you update something, we keep the original. If you delete a row, we still keep the original, right? So at any point, you can go back in time. So you can go back and you can say, what did my data look like a week ago? What did it look like 5 years ago? And you can check it out. You can see it exactly as it was. For the regulatory reporting use case, this is very helpful. So let's say that someone does a transaction, but they misprint, they press the wrong number, the report gets sent to the regulator. The regulator looks at this and they go, this looks wrong. Why is this? This number doesn't seem right to us. And then they can come back to us and ask us, why is this number wrong? Can you explain what happened here? And then regulatory reporting can go back to the time when the report was generated. They can see that, well, that number was wrong then. Half an hour later, there was an update where, this number changed. So we can go to that point in time. We can rerun the report generation. You get a new correct report to hand in to the regulators. And you have a very compelling story where you can explain exactly what went wrong, why, how, when. All of those things get answered.
All right. So now you know what our data lake is. Let's talk about a feature of it that me and Erland are working on, our refinement services, which we call our refiners. And these are essentially ETL pipelines that our users, other Goldman Sachs engineers, write, that reads data from the lake, transforms it according to the user's need, and then ingests it back into the lake. And these refiners, they can be anything really from, they can maybe join two data sets or rename a column, something simple, to something much, much more complex, operating over multiple data sets, performing very sophisticated transformations. With the refiner platform, we want our users to focus on what they are good at, which is their business logic. And while they do that, we in the Lake platform team, we will take care of what we are good at, which is the infrastructure around all of this. What this means is that the user, they will write their refiner, their logic of the refiner. They will define a set of rules for when these refiners should run. They can also set up SLAs. Then we in the Lake platform team, we will take care of the rest. We will manage the runtime. We will provision and scale the infrastructure. We will run the job, run the refiner when the rules are true. And we will manage the input and output data along with its entitlements. And we also provide a refiner framework that makes it easy for the user to write their refiner. And if we go back to the regulatory reporting team that Alan was talking about, this is a great tool for them. As he said, we do make millions of transactions in the firm that needs to be reported to different regulators at different times. And these are processes that involves a large amount of data and are under very, very strict deadlines. So if you just imagine a scenario where we have 3 different reports that's supposed to go, one supposed to go in London at the end of the day, another in New York, and a third in Hong Kong. Then the regulatory reporting team, they can focus on what should the data in this report look like. They can configure these refiners in the lake and let us know when we should run them. For instance, when an end-of-day flag is sent. Then they can be confident that the Lake platform will get them their data they need in time every day. All right, so that is one refiner use case. We do have a lot more. Right now, we have around 6,000 refiners live in the data lake, and they are written by hundreds of different users. And these are both numbers that keeps on growing, which is also true for the entire data lake at Goldman Sachs, which has a yearly growth rate of around 60%. And this means that eventually we'll run out of on-site infrastructure, which is why we are currently working on migrating our entire data lake infrastructure to the cloud, which also involves our refiners. And this means that we can easily manage and scale our infrastructure and our users, and we will help our users leverage the latest technology. But as I said, these pipelines, these refiners, they are written by the users, so they are therefore unique. How do we know for each single refiner, where does this fit best? On which cloud technology does this refiner perform best? That is a difficult question to answer. And if we answer that today, how do we and our users know that that choice that we make is still the right one in 1 year or in 5 years without a crystal ball?
Right. So this is where our solution comes in. So we have built a solution where you, as a user, you can write your pipeline, and you write it using our framework, and then you can easily run this anywhere. And in the future, if there is some new technology, something new and modern in 4 years' time, we can add support for that, and then this refiner that you built today, in 4 years' time, you can move it to that new thing that is hopefully much better for you. This is also very helpful even today, because if you're not sure, what is the best place for my use case, for my refiner, you can build it using this, and then you can try it out on all the different options you have. You measure it, you can see, which one is the cheapest, which one is the fastest, whatever it is you want to optimize for. You try them out, you pick the one that suits you, and you go with that one. For us as a platform team, this is also very helpful. So let's say that in a few years' time, we want to demise our on-prem SQL warehouses. We want to move everyone away from them. In that case, if your refiner is written using this, we can pick that up and we can move it to some cloud-based file store, for example, without you having to do anything. But of course, if I'm going to move someone's pipeline, I will want to feel very certain that it does actually work. I don't want to move it and then it breaks and then I'm there with the blame. So we have also spent and are going to spend even more time on developing a very solid testing framework for this, so that we can ensure that when you move your pipeline, it still works, it still does the same thing. So how have we implemented this? So as a user down at the bottom, you write against the Spark APIs. So Spark is an open source data processing framework. So you write your code against that. Behind Spark, we then step in, me and Josefin, our code, and we will figure out where you're trying to run it. So you have a few different options. Can I just draw up here? So database in cloud or on-prem or file-based storage. We figure out where you want to run it. We pick the right Spark connector for you to use. And then we insert these small arrows here. So that's a small transformation that we can put in to normalize the data back to the way you expect it. So since the data lake is a centralized platform, we have the schemas, we have the data types and the column names and all of that from the producer when they uploaded the data to the lake. So now we can use that knowledge to make sure that that's exactly what the data you get access to looks like. It conforms to that. So you can write your code today, and in the future, in 4 years, if there is a new and better technology, we can add one new of these small transformations, and your refiner will still run the same because the data you get looks the same. Then we have the testing part. Here we first have the first part are just ordinary unit tests that every developer writes, where you write, you test your happy path, you test your edge cases, you test everything you want to test. And we've developed a platform where you can let us get access to those tests. So you run it today, you build it today, you test it. In the future, if you want to upgrade to something newer, you can run these again, or we can run them for you, and we can see that everything still works. And another important part is our simulation. So since the data in the data lake is versioned, we can run a pipeline twice. So you run it, we roll back the data to the same point as when you started the first run, and we run it again. And ideally, this produces the same data, right? And we can do this, so we can run it against, say today we run it against on-prem SQL database, and then we run it against a cloud-based file store. If we run it against the same data, both of these should produce the same output. If we keep doing this for a week or a month, then I can feel very confident that your pipeline still does the thing you expect it to, even after we change the underlying storage.
Right, so that was a summary of what we have built so far and what we're currently working on. Our objective for this year is to start onboarding users to this new platform with portable pipelines, along with the testing framework that Erland just mentioned. Next year, our focus will be on integrating this with additional cloud providers. We are still in the early stages of this journey. We've learned quite a lot so far. Our biggest takeaway has been the benefits of simplicity. And that is why we chose to name this talk Moving 6,000 on-site refiners to the cloud without lifting a finger. We found that last part about not lifting a finger to be essential. Because for everything that we can streamline from our process, every action that we can streamline, how small it may be. It can be a simple thing such as removing the need for the user to write 2 additional lines of code. Really gives both us and our users great returns in terms of the time and effort that we spend. And therefore, for a platform of our scale, simplicity really needs to be central in everything that we do. Thanks a lot for listening. We will be very happy to talk more about this with you. We'll be here by the stage or around in the conference area afterwards. And you can also add us on LinkedIn. We can continue the discussion there. If you are interested in engineering at Goldman Sachs in general, I would advise you to check out our new developer blog at developer.js.com/blog or follow us on Twitter @JSDeveloper. Thanks a lot for coming.